Hi, in this tutorial, we're going to look at that National Weather Service data from the Climate Prediction Center, learn how to bring that into GIS as text files, and manipulate and manage those in our GIS. You can see if I go to the website for the National Weather Service Climate Prediction Center, you can see I have U.S. daily air temperature in degrees Fahrenheit. I also have snow depth, precipitation, pan evaporation. For the focus on this tutorial, we're going to look at daily maximum temperature. You can see some directions about the data, so some types of pseudo metadata that we've talked about before. If we click on the daily maximum, you can see up at the top it's created from a FTP site, and you can see the headings that we have here. We have a lat, a long, a mount, an ID, a station name, which is going to be a unique ID to identify each of these places, the state, the city, and then maybe some placeholders for the elevation and time. This is what we call comma delimited. But you can see here I got 50.37, negative 114.42. So you can see these are using our geographic coordinate system where we measure latitude and longitude. We've talked about the idea of precision before. So you can see that we only have two-digit precision, meaning if 1 degree is equal to about 6970 miles, at least in the latitude direction, we're looking at about 0.7 mile precision for these particular stations. So we'll get these within about 7/10 of a mile of where they could potentially be because we don't have as good precision. But what we want to do is bring these GIS data into a GIS and turn these into spatial data because right now they're just text files. So there's a couple ways I can do this. I'm working in Chrome, so I can just right mouse click here and click Save As. There's probably some other options that I can do over in my options. I can probably save the data here if you're working in Internet Explorer or some other web browser, but I have it pretty easy, so I'm going to click Save As. I can cut and paste this into an Excel spreadsheet if I wanted to. And I click Save As. And I'm just going to save this in my temp folder. So I'm going to store this as AirMaxGIS 2017-09-08.txt. So that's the extension. I'm just going to save this. I'm going to save this in my temp folder here. Okay. And I have other GIS databases that are sitting there. Okay. So I'm going to click Save. And there we go. And if I were to open this up in Excel or open this up in Notepad that I did here, which is the default for this particular file extension, you can see it kind of looks like junk. But what I'm going to do here is I'm going to bring this into my GIS. So I've opened up a new project here. You can see my North Carolina counties. I'm going to click Add Data. I'm going to go to my C. Go to my temp. I think I have something here called AirMax and 2017-09-08.txt. And I'm going to double click on this. And you can see it's been added here as a standalone table. So we've talked about the difference between standalone and attribute tables. I'm going to right mouse click and click on Open. Okay. And now you can see the files here. You can see the fields and the attributes here. Okay, so I've got lat, long, amount, ID, state, city. You can see suburb in Alberta, elevation and time. What I really want to focus on is the amount, the lat, and the long. So these are the maximum temperatures for these particular areas right here, for these particular stations with these particular latitudes and longitudes. I want to add these to a GIS, so I can right mouse click and click on Display XY Data. Okay, so you can see my file here, my field. My X field is going to be my longitude. Make sure it's negative because it's positive. You're going to be over in China. Okay, remember, negative is to the west of the prime meridian. Positive is going to be to the right or to the east of the prime meridian. My Y field is going to be my latitude. We don't have a Z field in this particular instance here. And my coordinate system or my coordinate system of input coordinates, I have those units in the lat and long field as degrees, so I need to specify them. Projected coordinate system name, NAD, state plane, 83, North Carolina FIPS feet. We need to change this. So I'm going to click on Edit. And I'm going to go up and look in my geographic coordinate systems. So I can click on Geographic Coordinate Systems, click the plus sign, and I'm going to click on the World Geographic Coordinate Systems. These just basically, and we've talked about these in class before, these specify the semi-major, semi-minor axis, the ellipsoid, and all the input parameters that measure how far a degree is, essentially, because the shape and the size of the Earth isn't necessarily changing as much as our ways to measure it even better. So I'm going to click on WGS 1984. You can see all of the parameters that go into this. So the semi-major axis that I've talked about, distance from the center of the Earth to the equator, semi-minor, distance from the center of the Earth to the poles. You can see these are slightly different, and then this flattening ratio. I'm going to click OK here. So now we're telling it that it's in degrees. Okay, so prime meridian angular unit is in degrees. And I'm going to click OK. Now, this says it does not have an object ID field. This is going to be very important. It says after you create this layer, you can export it to a shapefile or feature class if you need these functions. Remember what an object ID field, that is the relationship between my attribute table and the features on the map. It's of the utmost importance that we retain or create those features here. This is telling us when we create this layer or this resulting event, what we call an events layer, it's not going to have those attributes, so we need to create it ourselves in the future. I'm going to click OK, and now we can see these features here. Okay, this is what we call an events layer right here, so it has some kind of attributes. I can open up the attribute table, you can see my source, and symbology. I can play with these, but it's like it said before, I'm going to right mouse click and go down to the bottom and click on Data, Export Data. Okay. I'm going to store this somewhere. I'm going to go to my C, okay, and you can see I've got my database connections there, so you might need to create your database connections at some point in time with those temp. And I'm just going to save this in my folder here. I'll just call it Hi Mom or whatever here. Okay. I'm going to call this NC. Air Max. If I remember the date, 2017, 09, wait. Okay, so you can see that I stored it here as a feature class. There's a couple different ways that I can store it here. A database feature class, file and personal geodatabase feature class, or a shapefile. I just stored it as a file geodatabase, and you can see it's up here in my cylinder. Gray cylinder, which represent this, and you can see I've got 5,624 features. Okay, now this is now a full-fledged feature class. Okay, so this is not an events layer. This events layer does not have as much functionality as a full-fledged feature class. I can remove that, and now I can play with this. So I can do something like selection by attributes. I can do selection by location. I can click, I can select all the features from this that intersect with the feature layer within 50 miles. So maybe I want to just look for everything within 50 miles of North Carolina. So if I do some sort of interpolation that these values outside of North Carolina will also be included for that. So if I'm creating a North Carolina data set or whatever I want to do. Last thing I can do is I can attribute these. So I can go to my categories, I can go to my quantities, whatever I want to do. So I can look at my graduated symbols. Under my drop down, I can look at the amount, and you can see what my maximum temperature is here. Okay, and I can manipulate those so you can see where it's high, where it's low. You can see it's relatively low, these max temperatures here, relatively high, probably in the western part of the United States, or the southwestern part of the United States here. Okay, but you can see here, I tried to focus this on North Carolina, and then we can export these features or whatever we want to do.